Hey everyone, welcome back to the DGA YouTube channel. In this video, I want to be talking about the challenges of building a decentralized game. In previous videos of this series, I was talking about what is a decentralized game, how do we build a decentralized game, and why do we want to build a decentralized game. So, it would be silly of me to tell you about all the great things of decentralized gaming without telling you some of the pain points, some of the challenges that we have. I warn you that this is going to be a long one. It's a bit difficult to condense this into as small time as I can. I've written down here 10 points. It's probably more than 10, but I've made it 10 such that I have 10 slides, and I'm going to try to blast through this as quickly as I can. Here's the summary. Decentralized networks have few experts. The open source mindset is not widely understood. There is an issue with bots and a difficulty of banning. We really need determinism. Randomness is a bit of a pain in the ass. Consensus is important, especially the speed of consensus, I should say. Finality, especially is it probabilistic, or absolute. It's a problem, it's something that needs to be thought about. Scaling is generally a problem for blockchains in general. It's also going to be a problem here for decentralized games. Related to scaling is also game complexity. Also the economics behind the game and that of the network. There's two kind of problems, shall we say, that interweave with each other. They're not exactly the same, but they're definitely related. The autonomy of the game, the fact that it's persistent, the governance of the game, privacy is a big one because blockchains are public, and then lastly about the usability of blockchain technology and that of account management. I think everyone knows that decentralized networks are fairly new. Yes, the internet has its origins a few decades ago. The World Wide Web is sort of from the early 90s. And then, we have examples of, say, file sharing networks like BitTorrent, etc. is older than blockchain, but it's not super old. And some of what has been learned there doesn't necessarily apply. Blockchains themselves, if we look to, say, Bitcoin from 2009, that's really the earliest. It is the earliest blockchain network, and that's kind of in many ways a starting point for us and trying to find experts in this field to help build a decentralized game. That's not entirely fair, but the point being is there aren't really experts that have 10 years experience. Even 5 years experience is difficult. That means it's difficult to hire people, and even those that you do hire, even if they're an expert within one particular aspect of a decentralized game, if they're an expert of decentralized technology, they're probably not experts at building decentralized applications. So if they're an expert of actually building blockchains themselves, it's unlikely that they're also experts in building decentralized applications. And that's a challenge. Open source, I think, is still misunderstood. In the blockchain world, it's the de facto norm, at least it should be. And yet still, many people building decentralized applications still make it closed source, and arguably it's not really a decentralized application. The thing that people don't quite understand is that the value of the code is not really the valuable part. People think that it's easy to steal the code and therefore make money. It's easy to copy the code, to fork it on GitHub and then to deploy it somewhere else. But the valuable part is actually in the overall execution of the project and of managing a community and getting everyone to work together and coordinating that. Having the community come together and help the project really fly is actually more important than the code. I mean, you can't really look at one in isolation. If you have all-star coders and you have this great GitHub repo, but you don't have any community, then you don't really have much of a product, or much of a project, I should say. And that's a problem. You really need more than just the code. So the fact that it is open source isn't really an issue. Actually, if anything, I think it's a benefit. I think there's many benefits to being open source. So maybe I'm not explaining this in the absolute best way. There is a great blog here that I'm linking on the slide by Jesse Waldron. This is on the A16Z blog. He describes what I'm saying pretty well, and he does it in a better way and more thoroughly. I would say check out that blog. Okay, bots and banning. If you have a decentralized network like Bitcoin or Ethereum, it's generally accepted that you can't ban an account. It just doesn't happen. And this is part of the principle of censorship resistance. Now, if you can't ban, what does that mean for botting? In a previous video, I've said that cheating is basically impossible for decentralized games. That's something that is explained a little bit better in previous videos. I'm not going to explain it here. So let's say that, let's just accept that that's true, that cheating is impossible, but botting is possible. So the bots are not exploiting the game nor finding some strange mechanic. What they're doing is they're just automating the movements within the game, and they're doing it in such an efficient way that a human could never replicate that. And generally that's a problem for online games, and generally it leads to banning, but if you can't ban, then you can't get rid of the bots. And then there's a question as, what does that mean for the game design of a decentralized game? Do you try to reduce the efficiency of bots? Do you just accept bots? That's part of the game, that's part of the game mechanics, and therefore we have to design everything, including the economics, in a new way to accept bots? Or do you have some magic mitigation, maybe some sort of proof of personhood? There are a few of these algorithms now, or at least proposals for algorithms. Do they work? I don't know. It's still pretty new. It's still a hot area of research, and I couldn't really say that the proof of personhood algorithms work right now. I don't really know. It's an interesting idea. Proof of personhood being proving that you're a real person rather than some bot, of course. So if we don't have that, does that mean that accepting bots is the only route? And it might be that is the case. I think more research has to be done here. Okay. Determinism and randomness. Determinism is something I spoke about in a previous video. I said that it's really important because it is. Your software, the blockchain software, has to come to the same result regardless of the hardware that it runs on. It has to be deterministic. Given some input, it has to give the same output. I think that's pretty obvious because it needs to, the node, regardless of the hardware, has to reach consensus. They'll have to reach consensus perfectly, basically. Okay, there's some caveats there, but anyway. The other thing is that you can't have your code throwing random errors or panicking in a strange way, such that the error that comes out is unpredictable and differs on different hardware. You can't have that. You must have your code behave in such a way that it handles problems like that gracefully, and the nodes just don't crash. I'm not going to go into a lot of detail here. That's kind of like some of the main takeaways. This also means the way that the game is designed obviously has to be deterministic. You can still have randomness. Of course, the randomness is like a seed to give you this layer of unpredictability that people enjoy in gaming, is having some level of unpredictability. And it's nothing about gambling. It's just about having something which is new, something that you can't predict, obviously, in the naming of it. But then the question is, how do you generate randomness in a fair way? How do you do it in a way which is public and is done collectively? And that's something which is difficult. There are obviously block caches, but they themselves have a lot of problems. If you want to create a proof of concept, then a block cache is probably fine. If you want to really get to production, then maybe there's another way you should be handling that. I also mentioned in a previous video about having a game that takes a random seed from the chain, like a block cache, and then generating the result based upon that random number. And that's something that you can do. It's not the only way, but you can build up a lot of a game based upon that type of design. Okay, so 5th problem here. Hopefully I'm getting through this a little bit quicker than I hoped, because I know this is going to be a long one. The speed of consensus and the speed of finality even is a big issue for blockchain networks, and trying to kind of combine a game and try to mash the two together. Let me try to explain it a little bit here. Players will have an expectation of a reasonable time for completing an action. So if you go to your bank account and you open it inside the game and you take out an item, you expect that to happen pretty quickly. You don't want to be opening and then getting a little loading screen, a little loading wheel saying, processing or loading, when you're trying to do something like open your bank account and take something out. That's something which is pretty trivial, and in an online game, it's fast to do that. You have loading screens between big areas of maps, but you don't expect it for something simple like opening mail, opening a bank account, or doing something simple. Whereas with blockchain games, if you have all of your actions on the chain, for example, then there may be some processing time between you sending out the action and receiving the response to say that has done. So that's obviously a big challenge. If there's slow block times, then that might mean that the confirmation that your action has gone into the block would take a long time. If you imagine that you have a 10-minute block time like Bitcoin, you can't be waiting 10 minutes for your inventory to say, yep, you now have a sword here, thanks for waiting. That's going to be very bad user experience, and we have to get around that. Having faster block times does kind of solve this. So if you imagine having a 6-second block time or a 1 or 2 second block time, it's kind of okay, but still kind of on the edge for MMOs, which tend to be faster than that. Game animation can kind of hide some problems with the speed of finality. If you were like mining a rock and mining the rock is kind of slow, that's something it could be processing while in the background you're sending out a transaction to the server, to the blockchain, and then getting a response. There's something you can do there, but still, there is still a fundamental issue of speed. Related to that is about probabilistic and absolute finality. And, very much related, which is that you have this expectation that whenever you perform an action in a game, that it's done. You take a sword out of your bank, and that's it, you've taken it out. You don't expect the game to say, there was a reorg, you don't have your sword, you actually have to go back to your bank to take it out. It's a bit of a pain in the ass, and this is something which is an area of research, shall we say. If you have a chain which is probabilistic, such as proof of work, or the proof of work that we see, then you will probably have this issue. That's kind of the way it is. Fixes for that are to look at blockchains that offer Byzantine agreement, or if you have a finality gadget which basically provides you the same thing, then you get this absolute finality, shall we say, which is to say that once it's in a block and it's been accepted by the validators, then it's done. That will give you the better experience, but it doesn't necessarily give you the speed. So there's two kind of issues here that play together in tandem. Okay. Somewhat related also about the network itself. Scaling and game complexity, these two are very much interweaving with each other. I see scaling kind of in two ways. There's probably more. One is vertical scaling. I don't know if I'm using the right term. I call it vertical scaling, which is about faster blocks or faster actions per second. And then horizontal scaling, which is about the concurrency and the massiveness of your network. So massiveness being you have thousands and thousands of players, which I think a blockchain can handle pretty well. But how fast can you have actions from each of these thousands of players? Can they be performing, requests and responses from the blockchain in like a second? Possibly not. So there's kind of two scaling issues there, and some of this can possibly be solved with clever tricks in the UI, like I was saying with animation. it's maybe not going to solve everything. So there may still be a little bit of like stickiness and a little bit of friction that you might just have to accept with a decentralized game. I think it's worth having more like discussion there. Definitely we need more decentralized games to test this out and to actually figure out nice ways to solve it. The other one here, which I'm listing here, is the fact that the more nodes that you have in your network, then yes, it's more decentralized, but it also leads to greater issues with synchronization of data, especially if you are, proof of work and you're mining, and one part of the network has mined a block. It thinks it has the truth, and then there's another part of the network which has also mined the block, and they also think they have the truth. And then the two have to basically kind of fight it out to get the longer chain, and then you can have a reorg. That will sort of disappear with a Byzantine agreement sort of mechanism, but then at the same time you still have issues to think about with block propagation and the time there. So this all plays together about the speed of action, the speed of finality, and therefore the speed of gameplay. On top of that, the greater complexity that you have in your game, the more that each of these things are going to be slowed down. And that's where simple games can be done quickly, whereas complex are going to be slow. The other big thing is, if your game is fully on-chain, so you have a smart contract with all of the game logic, there is only so much logic that you can process within one block time, and one block time might be 10 seconds or whatever. Obviously, there's only so much computation that you can fit within 10 seconds. So having all of your logic for your game on-chain gives you a fundamental limit on the complexity. And that may not be the way to do it. I think off-chain solves a lot of this, but there's obviously pros and cons. I'm not going to go into the pros and cons, but I'm making you aware that this is a challenge, and I think there's more R&D to do here. Okay, economics and autonomy. This is a really interesting one. If botting is the norm, as I alluded to, then what does that mean? Do we need new economic models in order to make the player engage in the game and still have fun, even though there's thousands of bots? Or what? The other thing is, if you have a persistent and unstoppable network, what does that mean for the game parameters? Does that mean that the game parameters are fixed for all time, and therefore the economy is fixed for all time? Or how do we update that? How do we change that? Should the parameters be dynamic? Should they somehow respond? There needs to be a lot more done on the research here. If you can't have human intervention, or if you rarely have human intervention in the autonomy of the network and of the game, then what does that mean for the economic models that you're employing? So those are big topics. One other one I want to fit in here, because it's a big one for me, this is kind of my idea, is I have this notion of three currencies. And let me explain why I'm proposing this. And I think it's relevant here for when we're thinking about economics. Everyone knows that Bitcoin has something of a deflationary currency, as kind of the reward will decrease over time. I don't know if that's deflationary or just mildly inflationary, but there's like a cap on the total number. And there's economic reasons or game theoretic reasons for Bitcoin to do that. And it makes sense for mining and securing the network and validation. But what does that mean for the game? If you have an expanding player base, an ever-expanding player base, that means that currency will become more valuable. Okay, that's sort of okay, but what does that mean for the liquidity of that currency? If people are holding it, hodling it, they're not trading it. And that will be problematic for whenever you want to try to trade some sort of like mundane, boring item. The other thing is, if it's super volatile, like we've seen with Bitcoin, players and like non-crypto native players are not going to be happy with the volatility on their the value of their account. Like one day they're worth $1,000, the next day it's worth $500, and then the next day it's $1,500. Of course, they're going to be happy whenever the price is up over the long term, but not everyone is used to this volatility and the risk. So having a purely deflationary currency for your decentralized game, I don't think is the right way. On the other hand, we know that inflationary currencies are very normal for MMOs, and they lead to a problem of mudflation, but what they do very well is they account for an expanding player base rather well. You can mine it and you can get it really easy. Not mine. You can collect gold pieces, say, very easy, or credits very easily. And as the player base expands, everyone can get it. Everyone has it readily available. They don't have to fight with, other miners. And so the two together would maybe be some sort of happier balance. Now, of course, if you have all of your player wealth in the inflationary one, then you're going to lose it over time, and that is not so good. But yet the deflationary one is very volatile, so you have this strange kind of trade-off as to whether you want something super liquid but will lose a lot of value quickly over time, or something which might gain over time but then super volatile. And that led me to suggest, well, why don't we just have the middle path as well, which is to have a stable coin, which will give you rough wealth preservation. I know there's obviously real-world inflation, but I think compared to what we would see in mudflation of like an MMO, it's probably a lot better. That's something to keep in mind. If, of course, thinking back to what I previously said about the autonomy of a game, if you can't change the parameters very easily, such that mudflation is not a problem that you can sort of fix just like every other day and just take money out of the game, then having a stable coin as a middle ground, I think, is very sensible, and may actually mean that players don't try to get as much gold pieces as they can. There'll be other things which are valuable, and there'll be other currencies that they can trade with. And of course, naturally, this kind of leading on to, you go to the auction house of a game, as you typically have. If everything is priced in this deflationary currency, then the prices are going to be jumping around wild, and that will mess up the price of the sword. I know that NFTs are very typically priced in ETH right now. I get that, but I don't know that that's going to be the best for an MMO. I think there should be something a little bit more stable. I think the other two are a bit more natural for trading, but it would also be possible to offer some sort of decentralized exchange inside the game which can just freely convert all of these, some sort of market making. Anyway, I've said a lot. That's kind of a pet idea that I have, and I would like to see some company take that on and run with it, because I think it should work. Okay. Naturally, what I just said leads very much into governance. How do you change your economic parameters? How do you do these updates? How do you upgrade your blockchain network, and how do you upgrade the game? And if there was a huge problem, then do you roll it back? And how do you roll it back? How do you account for that? Whenever you upgrade the blockchain, typically you have a hard fork, at least with old blockchains, and that means that your old nodes and your new nodes are not compatible. Software like Polkadot and Tezos, they allow for on-the-fly upgrades, so you can have like a forkless upgrade. I know that that's not everyone's cup of tea. I think it's particularly neat. And then the other sort of solution here, which is even if your chain was super simple and basically never hard forked, which is maybe a consideration, you would couple that with off-chain computation and having most of the logic off-chain. But then also, how do you update that game, which basically runs mostly off-chain? How do you handle that? How do you handle it in a fair way? How do you balance the power that the devs have with what the community should have? And that's where, how do we handle player influence? Do you have the rough consensus like Bitcoin and Ethereum, where you argue on Twitter, on forums, on GitHub, and then you try to come to some sort of conclusion? Or do you go with coin voting like you see in Polkadot, Tezos, and a bunch of other proof of stake networks? I'm not saying which one you should take here. It's not really the point, but it's the fact is that this is going to be a new challenge for a lot of people who are building these games for the first time. If you're coming from the old traditional software gaming world, these probably weren't things that you ever thought about. Player influence and player governance was almost ignored in traditional games. I kind of complained about that in a previous video. Old school RuneScape is perhaps one of the exceptions, but most, you fight on the forum and then, the opinions are kind of lost in the wind. But here within blockchains, it's much more front and center, and you kind of can't really ignore it. You have to approach it head on, because the community to some extent own the network and they own the game in some kind of loose sense at least. So there is an expectation that their voices will be heard, and that's something that you have to deal with. Okay. Oh, this has been a long one. So, privacy. Privacy is important. Players, I think, expect that for whenever they're playing a game. But then, on the other hand, is that blockchains are public by design, and all of the data is public and easily available. So what does that mean for hiding some information like your inventory, your bank account, or even your position within a game? Not everyone wants to share their wealth. Some people want to be private. That's a personal choice. Also, things like position may be something of a strategy, or even your inventory is part of your strategy if you're doing PvP. You don't want to tell everyone what your strategy is or what you're holding. You want it to be secret because that's the way that you can maybe win in a PvP match. So then the question is here, how do you hide that? Can you hide it? Maybe you have to accept that you can't hide it. Maybe that's the new, this is the new gaming paradigm where people have to accept everything is open and transparent. Of course, I do think it's worth putting some research into thinking, how could we keep things private? For example, maybe we can have ZK snarks like we see in Zcash. Maybe that would handle the bank account. Maybe that would handle the inventory. But what about position? Maybe it helps. I know Dark Forest have something with position and keeping that secret, and they use ZK snarks. I'm not entirely familiar with their scheme to know if it's exactly the right one. Another sort of possible is having some sort of commit reveal scheme, which I think could be done in a simpler way with hashes or encryption. I have some thoughts on that, and I wrote a blog about how such a scheme might work. The blog, the idea is based upon something called open conflict that you can go and look up. And I thought I had quite a neat solution, but I don't know if the solution works. So something that needs to be thought about and something that needs a lot more R&D, as I probably said in every slide. Okay, this is the last one. There's actually more problems, but 10 was a nice round number, and this is where I'm going to stop for the problems. Usability of blockchain tech is a pain in the ass, let's be honest. A lot of us do it because we enjoy new technology, but there's a lot of people out there that don't enjoy new technology in quite the same way, and they don't want to have the hassle of friction. They just want to play a game. And I think people who are building decentralized games should do their best to make the UX as nice as possible in order to attract this larger player base. You're trying to build a game that's fun. You don't want to build a game that's only for like crypto geeks. I think it kind of defeats the point. There's such a much bigger world out there with many more people, and you should be building a game trying to get as big an audience as possible, or as big as sensibly possible. And the thing is, even for crypto geeks, it's actually still a bit of a pain in the ass. Some of these things are just not, like, sometimes it's just not fun. Like key management and password management is really, it's not fun. It's like we have to do it because we have to, but it's a pain in the ass. Things that players are not going to be used to coming from the old world is transaction fees. If you swing your sword, you don't expect it to have a cost. It's just get on with it. You're swinging a sword. You're killing a monster. This is new. With World of Warcraft or RuneScape or whatever, it's either free or you pay some subscription for the month, and then you can do as much as you want. In a blockchain game, there is, in many ways, for most cases, a cost. And that's the sort of thing, like if you have some amount of money, you're going to deplete that with the more actions you have. So it's not based upon the time that you play, like 1 month, but rather about how much. And that's something to be overcome. Yes, there's options for a free-to-play model. I'm not going to touch that in this video, obviously, but that has its challenges as well. And that would be a very good video, which actually, it will be another video. Lastly here, which is, if you do lose your password or you do lose your private key, you're kind of stuck. There isn't a centralized, easy way to solve this. With some caveats, generally you don't share your password or you shouldn't. And generally you don't share your private key or you shouldn't, which means that you have to manage it yourself. And how do you encourage users to have good practice around key management or around password management? And then when they lose it, that's it, they're stuck, because you can't just easily just reset the account. It just generally doesn't work like that. But maybe there's a way. within Polkadot, they have a social recovery module, which basically says that you can kind of set some people that have like an address to be, these are like the people that you should kind of contact in order to recover my account. Obviously, this can be done in a more programmatic way than like phoning up, customer service and saying, hey, can you get this fixed? Is it going to be sufficient? I don't know. I haven't really looked into that in sufficient detail myself, but I think it's something of a way of having a solution to this problem. And maybe there's more. Again, more R&D is needed. So that was 10 big challenges for building decentralized games. A lot of these challenges are things I've already listed in the book that I'm working on. It's an open source book. It's on GitHub. I really need more people to comment on that, to give me some input on the language and to give me new ideas. The main conversation that we have for this group, the DGA group, is on Discord. That's where we chat the most, and that's where I think people should come and join. We have a Twitter. It'd be great if you could follow us. We have a website. It kind of sucks, but we have it anyway. We're here on YouTube, so if you could subscribe and send some likes, that would be really appreciated. But of course, I think if you do anything, I would say to join the Discord and come and chat with us there. On a very, very final point, I'm just going to remind you that all of the links for the important stuff that I just mentioned in the previous slide will be in the description of this video. Okay, thanks for watching. It was a long one, but I hope you enjoyed it, and I hope you've learned something here, and I hope this is inspiring you to actually not to shy away from the problems, but actually to be brave and to confront them head on, and to be the one who's going to be the pioneer who's going to solve these problems, and therefore be like a champion for decentralized gaming. Because we definitely need that. We definitely need a lot more people working on these problems and solving these problems, and I think these problems can in a large part be solved. We just need people working on it, and that's just something we don't have right now. We don't have the money, and we don't have the people. Things are getting better, things are going in the right direction, but we need a lot more of both. So I want to encourage you, if you're watching this, to come and join us and to share ideas and be part of this journey. Thank you very much for watching.